2.4. You can cross out the top part there. We're going to skip that. So we're talking about differentiability today. The derivative exists for each point in the domain. The graph must be a smooth line or curve for the derivative to exist. The derivative fails to exist where the function has 1, a discontinuity, so that can look like this, where there's a discontinuous at this hole here, or there's a discontinuity such as that. Just draw some arrows there. So at these 2 points here, we would say it's not differentiable. Derivative fails to exist. The derivative can also fail to exist at a corner or cusp. And that looks like a really sharp turn right there. That's not a smooth turn, it's just a immediate sudden turn. You cannot take the derivative here because if you wanted to try and find the tangent line at this point, it'd either be this one here or this one here. We wouldn't be sure what direction to go because this is not a smooth turn. The last condition where the derivative can fail to exist if there's a vertical tangent. So this could look like something such as this. Well, you see there's a vertical tangent line here. You can't have a vertical line here, a vertical tangent line, because that would be an undefined slope if it's straight up. This question right here, we're going to identify points where the function below is not continuous and or not differentiable. So here's the thing. If a point is not continuous, it is not differentiable. This is one thing you have to remember. Differentiable. However, just because a point is continuous does not mean it is also differentiable. We're going to do this here. So when x is equal to -3, it's not continuous. It's not continuous, therefore it's not differentiable. Just to abbreviate right there. At x is equal to -2, you see the function's continuous here is continuous, but not differentiable. Right? If it's not continuous, if a point's not continuous, it's not differentiable, but just because a point is continuous does not necessarily mean that it's differentiable as well, because in this case, it's not differentiable. If you go to x is equal to 2, you can see the point is continuous, but not differentiable because it's a cusp, a corner/cusp. And then at x is equal to 4, it's not continuous, not differentiable. So, some true or false questions. Differentiability applies continuity. This is true. If a function is differentiable everywhere, it has to be continuous everywhere. If a function is differentiable, it's also continuous everywhere. However, the reverse is not true. Continuity does not imply differentiability, but differentiability does imply continuity. This is false right here, because just because something's continuous, like that, continuous function, it's not differentiable at this point because it's a corner. So be very, very careful with these. Any questions, please ask your teacher. Otherwise, you can get started with the practice.